Hello, I'm here to explain my project, Reduction of Cybersickness in Virtual Reality. Virtual reality is a steadily developing domain in the recent years. Virtual reality is a computer-generated environment with scenes and objects that appear to be real, making the user feel that they are immersed in their surroundings. Although the immersion is high, this causes the problem of cybersickness. Cybersickness is a form of motion sickness caused by virtual reality technology. This is caused by the alignment of the vestibular systems to the virtual world rather than the real world. We are trying to use the rotation and transnational snapping techniques to reduce the cybersickness. Simulator sickness questionnaire SSQ will be used to measure the user's cybersickness, and by using these viewpoint methods, we are going to reduce the cybersickness. This is the architecture of the VR Cybersickness project. In a high-end workstation, a VR head-mounted device that is the Oculus Rift or Quest is connected through the Unity 3D game engine. By this, we create an 3D environment that is running on Unity 3D game engine, which is experienced by the user. The user experience is tracked by using the Unity 3D game engine, and the user data is collected from the SSQ. By this, we'll be analyzing the user info. This is the data flow diagram of the VR Cybersickness project. The user input is fed through the Unity 3D game engine. Then the scene selection process happens. By using the local data repository, the previous participant data is selected and the scene selection and optimization process takes place. Once the optimized scene is sent into the rendering process, the scene is rendered via the Oculus headset and the user can experience the output. Again, the participant data is stored in the participant local repository. This is the first step of the reduction of cybersickness in virtual reality project, integrating the VR headset with a Unity 3D game engine. Here, we are connecting the Quest 2 VR headset with using the Oculus software as explained in the architecture diagram with the Unity 3D game. Following the integration of the VR headset with the Unity 3D game engine, the next step is launching the project through the Unity Hub software. Once the project is launched, the user will be in the Unity game engine. This is where the cybersickness experiment will take place. This is the Unity 3D game engine where the project runs. As you can see, the project has three scenes: the menu, the tunnel snapping scene where the experiment takes place, and the end credit scene. The first scene is a menu which consists of many user interfaces to collect data from the participants. Since a single participant is required to participate a multiple number of times to get accurate data on the cybersickness, this menu is helpful to record the participant details. This is the second scene in our reduction of cybersickness project, a specially created virtual environment to test the viewpoint techniques, rotational snapping, and transnational snapping. The user is allowed to use this VR environment, and the rotational snapping and the transnational snapping techniques are used on the user. By simultaneous run in this virtual environment, the user data is collected through which the cybersickness data is calculated. Now we will see the execution of the reduction of cybersickness in virtual reality project. The user will be presented with this menu to enter the participant details. The participant details are stored in the repository for future reference for optimizing the scene as per the participant data. This is the virtual environment where we set many participant uses to calculate the cybersickness levels while using the non-snapping techniques. Then we apply the rotational and transnational snapping techniques to allow the user to move in the environment. The user explores this environment numerous number of times with different values of the rotational snapping and transnational snapping values. By this and using the simulator sickness questionnaire, we calculate the cyber sickness values. Once the participant completes all the objectives in the second scene while applying the rotational and transnational snapping techniques, the user is presented with this third screen. This is the end screen so that the user can remove their virtual reality headsets. These are the various code files used in the reduction of cybersickness in VR project. All these codes are written in C# language, as C# is the only supported programming language in the Unity 3D game engine. The game.cs file consists of the processing for the participant data, which helps to optimize the scene according to the participant data. Button and action. This code consists of the various actions should be proceeded by the avatar in the game while running. This GUI.select.cs code is the graphical user interface code that is used to collect the data from the participants. Camera.rotation is a code used for camera rotation outside the VR headset. This allows the user to move in the VR environment without the VR headset just by moving the mouse. This is the procedure and the results of applying rotational snapping in the reduction of cybersickness project in VR. Rotational snapping operates by eliminating the frames during the viewpoint rotation. In other words, the rotation becomes discrete as the viewpoint snaps. As you can see in the first frame, the non-snapping, where the rotation snapping is not implied, there is a continuous sequence of frames. Whereas when the rotational snapping is implied, the first and last frames are only present, and the in-between frame is replaced by a single long rotational frame. The graph here shows the effectiveness in reducing cybersickness and nausea in VR by the rotational snapping technique. The graph shows the SSQ scores of the rotational snapping, where the RS results in significantly lowering the SSQ scores. The x-axis is time and the y-axis is the nausea score. The RS reduces the cybersickness by 43%. Similarly, this is the procedure and output of the transnational snapping technique used in the cybersickness project. Transnational snapping is similar to rotational snapping, using discrete movements for transnational displacement during both forward and backward movement. As you can see in this image, where non-transnational snapping is implied, there is a sequence of frames. During the translational snapping, the first and last frames are present while the forward and backward movement frames are replaced. This is similar to the teleportation used in the video games. The graph here shows the effectiveness of the translational snapping in reducing the cybersickness in virtual reality. The graph displays the total SSQ scores for translational snapping. This reduces the cybersickness by 47% according to the participant levels in the SSQ. The graph also displays the nausea scores taken once per minute, which is increased over time due to the exposure to increasing cybersickness effects. By using both the rotational snapping and the translational snapping, as you can see, these techniques are highly effective, and rotational snapping can reduce the cybersickness by 43% and translational snapping can reduce cybersickness by 47%. Thank you.